How are
Hey everyone,
you?
thanks for joining us for another LinkedIn Live on OpenTower Designer. If you joined us last time, we covered monopoles, and today we want to cover self-supporting towers. So we've got Pankaj Taneja here, who is definitely a program expert, and will walk us through kind of the different facets of self-supporting tower analysis and what makes OpenTower Designer unique. The cool thing about LinkedIn Live is that we can see all your questions come in live, and we can answer them directly. So definitely feel free to interject if you have any questions that come up along the way, and we'll be happy to take those. With that, let's go ahead and just get into it. I know you have a really cool model that you built up here for us, Pankaj. Uh, First thing that I see that stands out from the last one is the linears, the linear appurtenances. I was
Yes,
wondering if we could dive into that. I know we've got some kind of unique features in OpenTower Designer uh, that make layouts of linears nice, and we can cover any different settings that we might have depending on what the user wants in terms of wind load calculations, things like that. So
sure, definitely. Well, you have a good eye definitely on that part that you picked up those feed lines. Yeah, so feed lines, as you know, that they are like linear loads, and they are contributing to the tower loading a lot. So with discrete, you have a local load, but the linear load is like really going from top to the bottom. And if they are not aligned properly, you might see extra torsion to the tower and all that stuff.
mhm.
So, so there are softwares, every software has its own way of modeling these logics, right? So we thought about it, and again, I am very happy that we work with our partners and our owners, that the brains sit together, come up with an idea, and we did something. When we did something, we realized that, oh yeah, this looks so good that at least it will allow the users to model their field lines very accurately.
Mhm.
So, giving you an example, let's say if you wanna, add new field lines. So we have a tool location under navigation tree. If you go to appurtenances and then you say double click on linear, it will pop up this window for linear. So here a lot of things are happening. So things are happening in the sense that we have a attachment and we have the appurtenance. So most of the times I will say that, like, some in some cases the field lines are directly flush to the leg of the tower. You know, they are, because those small tiny field lines, which are like sometimes for the lightning rod, or maybe sometimes for small TMEs, or maybe something like that kind of the beacons and everything. You can easily flush those to the tower leg with put a clamps, and then let it run on the tower, right?
Definitely.
But others, like like let's say you have like 12 antennas on the top of the tower, right? You're running those 158 coaxes onto those antennas, and they will be either modeled either on the face, or maybe along the face, in the along the center of the face, or maybe with some little offset on both sides, and on the top, like could be inside the tower, like between the legs and all that stuff. So there is a lot of that stuff there. And how do you model it? Because loading makes a big difference, because we are trying to analyze these towers, right? And our the only thing we need is the perfect tool which allow us to uh, model, or maybe create add these feed lines properly on a tower.
Mhm.
So when I was referring to that one, so here you can see that my other screen, there are some linear attachments, and then I have some feed lines. So the feed lines here, you define it that, hey, this field line is going to which ladder. So think about this way, how easy the work is. So you know that where my field lines, on what ladder it is going to be. So not every time you come to the tower, like, hey, oh, maybe it's on this one, or maybe I don't know where I put it, like, but here you have the clean picture. This is the attachment, this is the field
Right. So in
line,
the
right?
top, do you have banjo brackets or
Yeah,
ladder,
yeah,
and then in the
yes.
second down below, you've got the actual feed lines
As field
themselves,
lines on it.
and then
Yes,
in
yes,
this
yes.
UI right here that we have down below, you can actually organize them, the
It,
feed lines, whether how
sure.
many per row, how many per column, and then actually stick them on the
Yep,
ladder
yep,
or
yep.
the brackets.
Sure. No, I'll talk about this one in a minute, but I want to show you that you brought a very good point here, like banjo brackets, right? So OpenTower understands the difference between a ladder and a banjo bracket or a T bracket or a waveguide bracket. When we say it understands means, T brackets are when you buy a T bracket, you buy a one piece of T bracket and you buy multiple pieces. Ladder is like a one section, one assembly of a ladder. It could
Hmm.
be a 20-foot section or it could be a 10 feet section, right? Or 5 feet section. So when we model these, we allow the user to provide us the proper information that how many T brackets are there. You know, you don't have to do hand calculations saying that, oh, you know what, I have 50 T brackets. Oh, let me calculate the CA front, CA side. Oh, convert back to the linear. That's too much work too. So
Right.
why not just have it simple? Hey, you have a T bracket, define the front area, side area, and allow me to enter the spacing of the T bracket. I'll do it and it will show up. So let's talk to this freeline tool, which is definitely an art we have created. I love this one. Like I can spend all day on it, and I saw the benefits of it. Why I'm saying that I love it because the benefits are, we have tools. There are a lot of softwares in the market, right? And everybody has a different way of taking care of the loading and everything. But our our standards are improving as well. Our standards have put together logics like, hey, how to do the shielding, how to do cluster formation and all that stuff. So that's where this tool helps everybody. So here you can see that I have these 12 cables, right?
Hmm.
And I have placed like four blocks, right? And
Yep.
then I have some elliptical field lines right here. You can see that. And look at this one. It's not only like you get confused. Hey, which one is what? When I click on something, it gets yellow. It just tells
Awesome.
me that which I'm working on it, which I am thinking about. Look at this. We draw elliptical as elliptical, not
Gotcha.
considered as a round, because it does make a difference. When it's you have only one field line elliptical and you model it, front and side area will be different. So that's kind of thing so why I'm showing that this is important, because our codes talks about cluster formations and everything, and I want to show that to all our users that this is the flexibility of the product. It's not like if you have only one set of cables will be considered as cluster or not. It's a combination of all the feed lines together, and then application checks whether it creates a combo box or not.
Hmm.
So that's where it is. And here you can see that I have one here, and then these are on our T brackets, and then if there is a climbing ladder, I put it here. So cluster doesn't show up in the climbing ladder, but I'll show it right here. So here you
What's
can see that we
what's
draw.
this? What's the spacing required between different groups before it's considered a different cluster?
Well, so it all depends upon the dimension of the feeder. There is a logic of three times the minimum dimension of the whichever
Mm.
is the shielding. So we look at this way, that how close the other field line is it meeting the code requirement?
Hmm.
Okay, if it is, then it should club together, not act as a separate. Because think about this way: if you have a whole bunch of group of field lines, right, together, and or if you apply the load on each field line, it will be a drastic change, right? It will be impact of the load will be different. And the beauty of that one is that we generate the internal calculations of like how it's happening, whether it is the EPA for individual feed line or what is the EPA of cluster. It have all that stuff is populated in CSV for the user to read it.
Beautiful.
And it breaks into, like, let's say if I have a feed line which is going, let me uh, let me talk a little bit more about this part. That let's say if this,
Sure.
you see that there is a 250, 260, 298, right?
Hmm.
Let's say if I go to 255.
So you're just changing
So
the
now,
elevation. You're looking at the tower, right
yeah,
there.
and now, yeah, and look at this. Now I don't have some field lines, right? Can this make a cluster again? We don't know, right?
Right.
Or maybe not. If it's not, it will create a separate clusters for you,
Hmm.
and CSV will populate separately for you. So that kind of thing. And we do another thing also, like let's say if these field lines are, they would have close to this area. Can you see my cursor?
Hmm.
So, and if I'm applying the window on this side, it will automatically shield the field lines inside the tower, the one which you see it. application automatically does that, and it will report that, hey, this was the fielding load, the area is 0 because it's all shielded for this direction. It's not like for all the direction it will be using 0, for only that direction. So it's all driven in such a way that each direction plays a big role in terms of field line calculations. And so this is like again, I definitely love this one. I'm not
Yeah.
sure if you have used it or not, but I
Yeah,
really like
definitely.
this.
I was wondering if you could showcase how you kind of manipulate these around, maybe change the
Oh yeah,
orientation of
oh yeah,
them,
oh yeah, yeah, definitely.
move them around on the ladder.
Sure. How about this one? Let's do a very quick one in this one.
Sure.
So let's say I will say that they are stacked on 6 on 6. Okay. And I have tools here. Look at this. So if I want to place something very closely, right? So let's say I want to bring these field lines. I'll say apply to attachment configuration and I'll click right here. Now I
Nice.
have this one. Oh, these are not placed properly. Oh, that's
Hmm.
okay. If it's not, you can always place it the way you want it. Oh, still it's not there. Okay. You can say select field line and you say I want to move it right here.
Easy as that.
Uh, oh, easy. And think about this way, because you are looking at pictures, you can easily place the freelance where you want to.
Hmm.
You don't have to say that, oh, okay, well, should I put a lateral offset of 0.24 will work or 0.23 will work? How much time we are spending on 0.24,
Right.
0.23? Rather than that, why not just spend time on like, scrolling with the buttons and, up and down arrows and get it done. And
Hmm.
look at this one, apply. It will update it based on what I have.
Awesome.
Okay, now let's say now this elliptical. Elliptical, as I said, like it does play a big role. So you do 0, 90, however you want to do it. Look at this. We rotate the free lines. I'll say apply and click. Yeah. So again, wherever you think is the best fit, you apply it.
Perfect. So we were talking how I took a poll on LinkedIn to see kind of interest from our viewers on like what topics exactly they'd like to see. We got some interest on mods. So I was wondering if
Oh,
you could kind of showcase like a real world example of maybe where we need to add some secondary horizontals to cut down on the unbraced lengths
mhm,
and how you would approach that using OpenTower Designer.
sure. So this is a this is a very good question. Like we all go through with the all these towers have gone through different life cycles and they have loading changing day every day. Maybe I'm exaggerating a little bit every day, but it happens.
Yeah.
So now, so what happened is like so there are things like we have design drawings, and then over the period of time these towers gets reinforced. But sometimes we don't know which reinforcement went onto the tower or whether it went accurately or not, which part, which got missed or not, or how to maintain the history of the tower, right? So that's where this thing I really love the Open Tower workflow is that. Let me show you one thing. If I will say that I want to just see my bare tower, let's say this is in few clicks. I'll say one click. I didn't say one click because few clicks in the sense it's gonna update the geometry of the tower based on the original design drawing. You know.
Got it.
So this is my original design. Okay. So I modeled this tower based on a drawing and I created it. And now if I want to analyze it, I put the loading on it so it might fit with the
Hmm.
today's loading.
Hmm.
So now I want to I don't want to change my design drawing because tomorrow, let's say due to some reason, I want to remove all the reinforcement and put the new reinforcement
Right.
again, but based on my original model, right? I don't want to have a cleaning the model or
Undo
create a
all
new
that work.
model,
Yeah.
all that work. So why we need to take the pain? Your base geometry is always there. So that's why you say that go to the modification tab we have. If you can see it on my left side window
Yep.
under the navigation tree. So there we have the modification layer. So you can right click on it, say create modifications, as many as you want over the period of time. I created some of them, and the UI of the mod looks the same as the section editor of our tower.
Got
And
it.
like because at the end of the day, data is the same, right?
Hmm.
You are what you are telling the application that, hey, I have modified these mods, these members. Can you replace those into our original tower?
Hmm.
Just I think it's taking some time there. So here in March 2021, look, I think what I did was like if I'll go to panel number 15, I'll show you that. So bottom section of the tower, I changed, modified the leg from a solid rod to a split pipe rod. Means a rod with a small pipe on top of it.
Got it. Yep.
Because that's a very standard way of reinforcing a pipe or
The
reinforcing a
legs.
solid
Yeah.
rod. So that's the easy way. So I want to
Right.
show that like hey, you have the capability of it.
Yeah.
and
Good
uh,
call.
and here you can see that I have a UPT. It means that it's maybe mainly meant for this tower. So or I can just add in my section database and I have the access to from there too. But here I did that.
Yeah.
And
For those
as you
not
were
familiar, UPT is user provided table. So it just means like
oh, thank you.
you've personally inputted that as a user as a custom section.
Yes, definitely. Thanks for adding that one. So you talked about the secondary horizontal, right?
Hmm.
So I want to show you something like let's say, uh, I will open a different one where I already modified it. So we will, and it will tell you which panels gets modified. So it understands the information. So here I said that secondary horizontal. Think about this way. I have a panel which has three bays in it,
Hmm.
and the only bottom bay is failing. Okay, my legs are failing, so I wanna modify that part. So what I'm gonna do is the best way to do in the industry is like just put the secondary horizontal
Yeah. Cut down the umbrace length.
under length of the leg mount.
Yep.
So look at this. I don't have to do the for the entire panel. I can just do it
Right.
only for one panel. And in the same,
Awesome.
I'm not breaking this panel into multiple sections for the analyzing purpose and all this stuff. I'm just keeping same as is. So that makes a
Yeah.
difference here.
That's great.
So now, because I have those mods, I'll show you that one. So here it tells me that mod 2021 has panel 14 and panel 15 modified only.
Oh, that's great.
Mod
So you
and
know exactly
modify.
what's entailed in that specific
Yes.
modification.
So tomorrow when I come back to work on this model, and let's say I'm trying to reinforce the model again, I know that which one has been modified already. I don't have
Hmm.
to look for the drawing somewhere. Hey, what was modified? I don't know. The trigger is that okay, this is a data, right? Everybody can say that, well, this is a data, okay, maybe I have data here, but how do I know that whether these are which one are modified or not when I'm building the tower? So let's say I'll show you that. So let's say I'm going to select the scenario. I'm going to create a scenario. I'll show you that. So in scenario, use base geometry is always selected.
Hmm.
You don't have an option to uncheck the base geometry.
Makes sense. Yeah. Then
So
you've got no
base
tower.
geometry, yeah, and then you have modifications. So you can click which modifications you want to use for this analysis, and then the other features which I say always that our vending machine. You pick up the our appurtenance group, appurtenance configuration, and wind definition, seismic definition, all that stuff. So with this one, and even like let's say if you have modified a particular panel twice, it's possible, right? Let's say today I modified that leg with the split pipe, but I put the connection of the split pipe, or which we call it as a connector spacing or stitch spacing, either U bolt or welded, right?
Hmm.
Let's say it puts U bolted, but with like let's say 10, what do you call that? Uh, I forgot. 14 inches or 20 inches or 28 inches spacing, right?
Hmm.
Instead of that, let's say you want to cut down that to 10 inches, but you want to keep track of that one there. So you can model you can model a panel modification to the same panel multiple times. You can come here, just define the hierarchy, which
Yeah, I
one
was just
has to
gonna
go
say. So,
first.
what difference does it make if I put one above the other?
So it's a hierarchy. So it means whatever is on the top will be taken and the bottom will be superseded.
Got it.
So that's how the engine we have implemented. And think about this way: it maintains the history of the tower. That's the beauty.
Yeah, definitely. Gets back to
So
the same thing we've been talking about is just having one model file for the tower to capture its entire life cycle instead of
yes,
20
yes,
models that different dates and different descriptions on them that are so easy to get confused.
sure. No, that's right. Because sometimes we forget, like, okay, due to server issue or something, I can send only one file to myself.
Hmm.
And you can put the modification, you can put the date on it, you can put the tag on it, what you modified. There is a proper like a
So did you
description.
activate the scenario with
Yeah, yeah,
the split pipe on it? I was just wondering if we could
yeah,
zoom in on that and kind of show
yeah.
how we
See,
represent everything to scale every time you put a new modification on the tower.
yes, and also it will tell you easily. Do you see some blue lines in the entire gray zone?
Yep,
So those blue lines are my reinforced modified sections.
got it.
So look at this. I don't have to worry about where it's reinforcement.
Hmm.
Look for it, select it, which
It's
member
just
it
clear
comes
as
from.
day.
Nothing.
Yeah,
Yeah, right here. It says my secondary horizontal right there.
got it.
And then you can see that, oh, I have some redundant horizontals here
Hmm.
modified. I have some redundant diagonals modified. And oh, you were referring about the split pipe. Here you can see that, the split
Nice.
pipe.
Yeah, that way if you put the decimal in the wrong location, you can zoom in and make sure that you're not putting a 5-inch thick pipe on the split pipe on your leg.
Yeah. And the question will come, oh, yeah, you are showing the split pipe and everything. What are the section properties?
Yeah, that's what I was just going to get to is how are we taking that into account for calculations once someone starts modifying members on their tower?
So that's where we have a user provided table, or there is another thing called SPC custom section. Okay. So what you do is you just, let's say you are taking another split pipe. Let's say I'm gonna add this one as 5.5 now. Okay. So you define your original section. The allowed thickness is the thickness of the member. If it's a solid rod, just consider half the thickness of the diameter to
Right.
make it a solid rod. And then you have what is the reinforcement you want. And let's say you don't want 180-degree, you can easily also do 90-degree also.
Mm.
You know, look at this. If I change this one, it's already changing my section properties and
Yeah, it's
all the
auto
section proper,
updating your section
all
properties.
yeah, right here. It's all getting calculated, and I can show you like user doesn't have to spend too much time on this part. Let's say if
Yeah.
we change it,
Well,
so
for
that
anyone
this
going
is
to an
the
external
confidence.
program or spreadsheet to get section properties, I mean, this is already a massive step forward. Just cutting
Yes.
down time that of going between different programs.
Yeah, and there could be a possibility, like OpenTower Designer is definitely meant for all the standard types of modified sections and everything. Like we have bent plates with a solid rod inside, bent plates
Hmm.
with a solid rod on the heel. When you have bent plates with the plates on it, you can define that where it is, how far it is, and all that stuff. Then you can say full encasement where you can put the split also that because
Mm,
you cannot
got it.
just slide the pipe on a top of pipe,
Right.
right? You need to cut into half and then put it into pieces because sometimes we have step bolts, sometimes we have sections, gusset plates, and everything. It's a lot of stuff there. So
Right.
that's why this all these features have been inbuilt. And let's say you are working on a section which is not fit in any of these categories. What you will do, right? We have a solution for that one too. Custom shape. Here you fill up the data of all the section properties, your area,
Gotcha.
moment of inertia, radius of gyration, section modulus, plastic section modulus, polar moment of inertia, warping constant, everything you enter it. And
Yeah.
you also tell the program whether this section should be considered as a round or should be considered as a flat. Well, everybody says, oh, why do I need to know that? Right?
Hmm.
Well, this is important because the wind load on the tower is based upon whether it's a flat member or a round member.
Right.
So it does make a difference, right? So that's why we have all these features. And similarly, let's say if you have that you have a standard sections which you will be using it, on a daily basis to reinforce the tower. You don't
Hmm.
want to create UPT. You can go to SPC custom section. SPC custom section. SPC stands for Structure Property Catalog. It's our catalog to maintain, which has the data for all the sections,
So
all
the
the
difference
different
here is that you're saving it to the permanent database
permanent
so that
database.
it can be used on any future projects. Whereas
That's
UPT
right.
is something, if you know it's something specific to that tower and you'll never use that type of reinforcement again, it makes sense just to go UPT route and just
Yeah,
have it live
and
in
it
that one
happens
model
like
file.
yeah, it means it happens. There is a give and take here because let's say if you are in a hurry, right, you want to finish the job and get it done because when you put the data in the SPC custom section, you have to close the OpenTower Designer and
Refresh your database, yeah.
yes, because the database has to go inside it, and kick in back to your system. So, but in that case, there is always a solution. It's not like the thought was given this way that let's have UPT as well as custom. So
Mm-hmm.
let the user decide who wants to do what, right?
Mm-hmm.
So that's pretty much. And then here you can see that we have
So
our
your
routing
point there was
information.
that we're auto-calcing the section properties, which are then used to calculate the new strength of the leg, for example, once you add a
Yeah,
split pipe onto it.
yeah, and yeah. So think about this way. Now we put a split pipe, right? So now the question will come here. Hey, how do you design this one? How
Mm-hmm.
okay, you calculate the section properties, but there could be a possibility that this split pipe is not fully welded, so it's not a monolithic
Yeah,
section,
I was just going
right?
to bring that up, the spacing of
So
connections and
yeah, so it does play a big role, spacing of connectors. And there, in our TI code, there is a clause where you calculate the slenderness ratio for a built-up section. So we use that thing over here too, because if it's a connector spacing, so we want to understand that how this small extra member added to the structure is changing the slenderness ratio of the member. And there,
exactly.
when we design it, we also check whether because there is an unbraced length. So the forces are going into these two members, right? If they are not fully welded, so it means the forces might these both can buckle differently also. So we'll
Hmm.
check all those different options internally to make sure
Great.
that the design has happened as per the code requirement.
Perfect.
And oh, did you see that? I have a T bucket right here. I just wanted to pinpoint. Look at that.
Oh,
So
gotcha. Yeah.
it's 4 feet bracing, 4 feet spacing. Answer.
Perfect. The other thing I got on the poll on LinkedIn was connection checks.
Oh,
Wondering if we could kind of dive into that, kind of
sure,
showcase the
definitely.
different bolt patterns we have, what those mean, uh, the
Okay.
limit states we're doing checks on.
Oh yeah, yeah, definitely. So we have this is all from manual. I just opened the manual for my
Gotcha.
reference to. I always refer my manual.
Yeah.
I know I wrote it, but I still forget the data to figure it out where it is. So here, so this is a very good point. Like everybody would like to know also. And when we were thinking about like implementing the connections, our partners thought like, hey, you know what? Like we are getting all these bolts and everything, but we all had the good mindset that hey, think about this way. If what is the difference between a 4A and 4B?
Hmm.
It's a pretty big difference. You know why? Because the when we say that the KL over R we calculate from the centroid of the bolt group. And if these are along the longitudinal axis of the member, so 4A might have a center of the bolt group between the second and third bolt.
Hmm.
But 4B, there is the central bolt group is same because they are in the you know
The same vertical plane.
same vertical plane, and it's not along the length of the member. It's a transverse.
Hmm.
So direction. And 4C, think about this. So the bolt groups comes differently. So this is why we have built up the library of connections that you define what type of connection it looks like. Application will take into considerations the design checks of the TI code defined in the chapter for connections like shear check, bearing check, and block shear check. We do all that stuff.
Hmm.
But the main thing which really controls our uh, information about this connection is the get the proper slenderness ratio of the members.
Hmm.
That's the key. And now, there are other options too. Some softwares, they just assumes the information, and we have given a user very much flexibility that how they do it. So AISC provides the standard gauge distance for angle sections. And how where you can define that the bolt scope and bolt is defined based on the gauge and everything, right? These are the auto values. Like if you keep it auto in the application, it will pop up these values based on
Hmm.
the dimension of the angle.
Yeah, C minimums.
But yeah, so but there are other sections like pipe and rod. Let's say rod doesn't get bolted, but it does sometimes when you put a flat on the front of it and then bend it and put a hole in it. So for those also we do it, and we assume that it's a half the width of the. member. So everything is already done there at that level. So these are very important, and that's why we have mentioned that the connection checks, and that's why we put this one in the appendix, that what these different bolt patterns means for the user. I have not seen, like, 6B at all or 5B at all
Right.
personally when I climbed towers, used to climb towers. But I did saw like 5E and the 5E 5C kind of things uh, on especially like pretty wide towers at the base with
Hmm.
the diagonals are getting connected, especially the K bracing. You will see these kind of connections very common.
Got it.
And there the users putting K factor to reduce the length. Why not application do the job for calculating the K factor, or maybe calculating proper K length to be considered for the slenderness ratio? And engineer will focus on the major parts, like, hey, how to reinforce the tower, whether my data is correct or not. All that stuff is important.
What are the limit states that the industry is most concerned about when it comes to connection checks? Obviously bolt shear. Do we start getting into bolt bearing or
We do that.
block shear?
Yes, 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 we do all that stuff. Let me show you. Even like for this one, give me 1 second. I'll show very well what it is. So when we do a connection check, right? So what we do is, for every checks, let me show this part. For every checks, we report the CSV files for the user to have the data. Okay. So when we say that, so here you can see that connection design results, member design results. Do you see this?
Hmm.
So let's say if I'll go to the panel number 8 here, just to show that one. So now, if you notice that, it will design each physical member connection, and it
Got
will
it.
tell you shear
So if you need
strength,
the
shear
granular
width.
data, you can come in here to
Oh
the
yeah,
CSVs that are
you
created.
yes, and it will does all the checks for you. It will show you everything: tensile yielding, block shear, and all that stuff. Everything is here. Even let's say if you have a gusset plate, you have model, and that gusset plate will gusset bearing also consider. At the end, you can see that, right? In this case, is a gusset bearing.
Got it.
So zero because in this
You didn't
particular model,
enter
I
a.
said no. I said that don't check the gusset bearing.
Oh, you checked the box for not checking gussets. Okay.
No, yeah. So that's why it didn't do it. But there's just one click box and you can do that. Similarly for the member design results, because reports needs to be concise, because we are shipping this report to the clients and everything. Who has the time to review all this data? Tell me.
Right.
It's difficult,
If
right?
you need
It's
to,
a
if you need to, it's there, but we don't want to overwhelm you with having all this get spit out within the program UI just yet.
Yes, yes. So that's why we have everything provided. We provide KL over R in different directions, like in plane, out of plane, buckling, and all that stuff, and provide you every information, even like the code requirement to what is the allowable limiting standard translation, like all that stuff. It's
Yeah.
provided, and the forces used, and also for which load case you know this member is governing for. Look at this load ID.
Got it.
So it's a very clean way of looking at the
Can
information what we are doing.
can you show the connection UI just so we can give everyone a glance at the different connection checks we can perform?
Oh yeah. So I'll let me show that one. So let's pick a panel number 13 here.
Sure.
Okay, I
So
was
we have
about to sneeze.
bracing
So I have geometry, bracing connections,
and
leg
leg.
connections, and design parameters. Okay. So when we edit a section, so here let's go one step back. Okay.
Sure.
So when we create a geometry of self-supporting tower, we have different tools here. You have a proper, just a structure overview. What are the different number of panels, section lengths, number of bays, bottom grid offset, width. You can do that. Then
Hmm.
we have an added section overview, which is a quick way of modeling the geometry of the tower. We have that one too, and it just opens another grid format where you can just enter the data very quickly, like right here. And look at this. If it's a reinforced section, it will tell you highlight here too. Hey, this is a reinforced section.
Oh, cool.
So it really helps the users to understand that, hey, you know what? Why this is blue? Because it's been a reinforced section. That's why it's a color coding part. So there, and then okay, let's go back to panel number 13 again. We'll talk more about it. So here we have different options. In the geometry, we have a face detail where you can just define the sections information and everything. We have plan bracing. I want to come back to hip bracing now, saying that you know hip bracing is a very important bracing for, especially for supporting the diagonal members. They are,
Right.
and we have a library for that. I think we are the only ones in the market who supports that library of the hip bracing as well. So if I will, this is our manual. I'm following the manual as you know me, like always, all the time. This is our Bible, so always refer to that one so that user knows that where to get the information when they're reading the manual. So here you can see that it provides the information. Again, this is the help of our partners too. Like they work with us and we all work together and get this thing nice cleaned up so that everybody can model it properly. So
Hmm.
there are different options here. But like the question comes, oh, I have these hip bracings, plan bracing. What if I don't have a bracing which is not a part of OpenTower,
Yeah,
right?
definitely.
So what are we gonna do there? Well, you can create your own bracing type, and you have the flexibility to create your own.
Hmm.
It requires some training. There's XML technology there, but we train people on that part. We have a training session for, it's a 3-hour training session. We go through the process called, hey, how to create a new bracing type if you want
Right.
to, and save it for your database. But
You taught me,
let me,
I'm no genius, so I can say it's pretty simple to do. So it's
good.
yeah, no additional cost, and Pankaj will train you up on how to add your own custom bracing if by some chance we haven't covered the one that you have on your project.
Yeah, definitely. And it's fun part. Like you can how much you can work with your models. Like sometimes we get limited to what software can do, and then only we design the towers based on that. Okay,
Right.
but here is not the limit. Here is what you want to design. Just pick the information. If you don't have the basic type, just create your own basic type.
Hmm.
Fabrication will happen based on what you design, right? So that's where the feature is, that it's you can do everything here. So let's
Right.
talk about the connections, the one you were talking about it.
Yeah.
So here we have, so here you define the connection for each member,
Got it.
you know, and you can have, let's say, uh, most of the time it happens that like all our towers are symmetric towers, but sometimes they have, let's say, somebody wants to put a ladder or something on a face, but they put an extra horizontal. But
Hmm.
that horizontal will see the wind, right? So what are you
Yeah.
going to do about that? So you can model that, those kind of different face bracings on different faces in OpenTower. So if I'll go to geometry, and here you can see that we have face A, face B, face C, right? But
Hmm.
they are all grayed out because I have clicked the option called all faces are empty. And
Just to speed up the modeling
so,
process.
oh yeah, definitely. So now let's say if we go to bracing connections, I want to show you that here is the one where I was referring to, check gusset connection. If I
Got it.
click on it, it will allow me to enter the thickness of the gusset plate, and then I can, check the bearing on the gusset plate as well.
Yeah, and there's the start pattern for all the different patterns of
Yeah,
bolts you're looking
and
at. You can input.
yes, and there are some towers in the industry where one side of the member has a different bolt groups, the other side has a different number of bolt groups, and we put the thought on that one too. Why not let's have option for the user if they want to define the different bolts at the end part or end
That's
of the
great.
member, they can do
So
that.
you can
So
turn
there
off
is a
that
mirror.
mirror.
Yeah, turn of the mirror command. You can have the flexibility to change
That's great. And then how about light
that.
connections? What do we have under those?
Oh, like connections, we have everything. You take the name of it, we do that. We have a flange, shear sleeve, splice,
And then how
and
about the tower, the base?
we have a base plate right there. You can enter the anchor rod's information,
Perfect.
and it will do the checks for you.
Perfect. I know we're getting a little bit closer to time if we want to keep this in like the 45-minute range. I also, in one of the polls that I asked to everyone on LinkedIn, we did get a lot of
Uh-huh.
interest, the most interest actually in foundation checks, because I think we might be one of the few out there who have built-in foundation checks.
Few? I thought like we are the only ones.
I'm just being
No,
generous in case in case I'm
no,
missing one, but
I'm exaggerating a little bit here, but that I'm sure there will be one. And this is the product, and the thought process given to the product is that the product completion is only happen when you don't have to use multiple resources to finish the project, right?
exactly.
Especially when it comes to the software, you want to
And
avoid that one.
that's the whole
And
philosophy behind OpenTower. Is it's
that's
literally
right.
you can come to the one brand OpenTower and literally accomplish everything you need for the tower lifecycle. For those of
Mhm.
you who haven't heard OpenTower IQ, it's another OpenTower product, more in the photogrammetry side of things, digitizing towers just from drone images, performing things like asset detection, the ability to
Mhm.
document any defects, all that type of stuff. So we might have a separate LinkedIn Live for that one eventually, but just to speak to how OpenTower is encompassing the full life cycle of towers, and so you don't have to actually go to separate programs and transfer forces or any numerical values from between programs.
Yeah, and for that, I think we need to invite our guru, Apurva.
Definitely,
He will. I want him to do it.
definitely.
I'm learning from him too every day, but it's still there's a lot of
Same
stuff
here.
to understand that. But let's come back to foundation.
Yeah,
So the thing is, as I was saying, like that, it's not like there is a problem that you have to use multiple tools to get the job done. But the problem is that there is a lot of possibility of error in transferring the data from one software to another software
exactly.
to
That's the
another
biggest
software.
risk. Yeah,
When it comes to foundation, right? So let's say we say that, okay, let's design our foundation with the maximum reactions, right? Okay, you can design that maximum reactions, but what it will be cool, like like you have a software which can do the analysis of the foundation and design based on
for
all the
each load
load
combo.
combination.
Yeah,
Yes.
instead of spitting out an overly conservative
Yeah,
design.
maybe you are like overly conservative, like you're taking the maximum axial load, maximum moment and everything. What if not, that load case is not the governing load case for you with all the
Yeah.
parameters,
Hopefully, the
so
person
that.
paying for that foundation doesn't find out that you did that conservative of a
Well,
design.
well, especially in this industry where foundation is the one which costs the most,
Yeah.
because digging, and especially where you have a very small place to work with it, like because look, we are talking about like maybe maximum 40 by 40
Hmm.
feet, like for towers like self-supporting towers. Monopole has a smaller place. How do you
Huge
take
vertical
a?
footprint, but very small horizontal footprints that we have to
Oh
work
yeah.
with. Yeah.
Yeah. So let's talk about foundation. We have a lot of different types of foundation. When I say a lot of different means, we have a isolated footing, we have a mat foundation, we have a drill pier foundation, and you can model guy anchor foundation as a guy anchor block, but you also can model the drill pier for the guy anchors as well, which I'm sure
Perfect.
will be, doing the session on it in the near future. So very straightforward options. Like it's a very simple UI for anybody to follow it. You have the data. Some of the things, like if you, let's say, if you go to blow count, if you don't enter it, you keep it zero. Application automatically does that for you based on the soil profile information you provide. And there are a lot of other options here. You can do ultimate bearing, net bearing, plastic and elastic. And then there are different types of soil. It has cohesionless soil, cohesive soil, and silty soil, and footing properties. There you have a footing length and footing height. You can define the top rebar size, bottom rebar size, and count bars. Let's say, in most of the cases, not, I should say most, very rare cases, you don't know the information about the foundation reinforcement. You can always put the zero here, and then you can always run it. Just ignore, you're just checking for the overturning and sliding.
Hmm.
But there is a feature we have implemented in our, I believe in a drill pier or somewhere, or guy anchor, that if they want to, because guy anchors are the ones where most of the time we don't have the information about the reinforcement, guy anchor block. So there we have an option called, hey, if you don't know just uncheck the rebar. So it will just
Got it.
you don't have to enter the information about it. So here we have a pedestal. You can have a circular, rectangular pedestal. You define all that information. There are options for superimpose axial load and pure bending. It's just a checks where what it does for you is like, did you see that the anchor board circle is like got activated when you're checking the pure bending? If you just say superimpose axial load, it's inactive for you. So there are
Gotcha.
some inbuilt calculations based on that one. And then we have material. You can modify the material of the grade, steel, and density of the concrete. It's
Perfect.
very
Do you
simple to what we have in drill peer as
did you
well.
happen to solve this one already? Were you able to
Oh no,
see
I
any
did not.
foundation output?
Oh yeah, I lied.
I'm not
Well,
sure if we
how
have
about
time, but yeah, if not,
I think
that's
sure
perfectly
it should,
fine.
we can do very quickly. It should not be
Okay.
that bad, and I can take questions in the meantime if you have any, or
Yeah, for
maybe
those
we.
watching, please feel free to submit any questions you might have while that's running, and while you guys are thinking up some questions. One of the other kind of random things that I remembered uh, about OpenTower Designer is bearing angle, and how does that come into play in terms of once you enter that value?
Okay, so bearing angle. Let's talk a little bit about. That's a very good point you brought. Like, let me bring my. Sorry, I have too many monitors to play with, and sometimes I get lost with which one I'm using it right now. So let me bring the our manual again. Okay, and let me show you that part. So here it is, right? So it does make it. I will show it in the application as well. So I want to talk about it. So when we go into the field, right? We we never like it's. I don't think it's ever possible that you look for what do you call that? Hey, where is the north? And my face should point to the north. Where is the leg? My leg point to the north. It happens to be like the way the I'm sure the EMF thing works over there. Like, hey, I want this region to be focused, this region to be focused. Then you orient the tower based on that one. So maybe so here it is. Like, we have a for three leg tower. We assumes that the leg A is pointing to north. Both are pointing in the same direction.
Hmm.
But if we say that they are not pointing in the direction, but you want to move the tower rotated with respect to north, so you define a bearing angle. So when you define a bearing angle, we just don't take the bearing angle for a reason. Means just for, hey, just sake purpose. Okay, yeah, you enter the bearing angle. No, we literally rotate the tower based on the bearing angle so that you can see it, visualize it with respect to your field tower to see how you're modeling it, because this might be important for, like, when you are entering the data for discrete loading, azimuths on the mounts, azimuths on the antennas. So instead of getting confused and moving your neck, hey, should I do this one, should I do that one, why not just rotate the tower in open tower
Got
and
it.
build it. So I think it's designing right now, but I'll show you that part. So in this way, if you remember the original orientation of our tower. Let me bring that our screen again. So this is how we build it, right? So this is the location with a bearing angle 0 degree. And in this case,
Hmm.
I think I have a bearing angle 30 degree. So you
Hmm.
see that we rotated the tower based on that. So now I can verify my data the way I want them, because I can take the images, or maybe let's say if you have the Open Tower IQ, your model is in digital twin, you can compare from there to there, apple to apple. you know
Gotcha.
so that's a one step ahead for moving towards the digital twin, to compare the live data with the as built versus as designed, as we
Yeah,
say.
yeah, definitely. That's
So
one thing I'll definitely touch on once we do an OpenTower IQ LinkedIn Live is how you can the beauty of overlapping the as designed and the as built models and reconciling any differences that might be there.
yeah. And here, like, you can see that we are designing each and every physical member. We just don't design for the critical only, like, because you have loading is traveling everywhere. It's just
Right.
the workflow has its own path. The forces will have to travel, and I think we are almost done here. So
Sure.
it's
And
just
then
it's just
I didn't mention that thing that everyone's seeing in the top right. If you open up your camera on your phone and just hold it over and look at that, it'll pull up our landing page that we've got put together for OpenTower Designer and OpenTower Mount Analysis. It'll give you access to put in a request for a 30-day fully functional license, our latest case studies, tutorials, all that good stuff that you care about. Just scan that and you can go ahead and pop open that page.
so
Perfect. So
here's what
here's
you asked
the
for.
all the limit states checked for the foundation.
Yes.
Nice, quick, easy to digest fail or pass on the right.
Yep. Yep. It gives you the
Beautiful.
entire information about it, and we do publish the graphs for shear and moment diagram for TI22H only at this point, and
Okay,
in near future we'll be adding it for G and F as well.
got it.
But the current version, which is available for anyone to test it or to use it, they will see that the TI22H has these curves
Got it.
diagrams as well. So,
And
and
then,
then we have
yeah,
a
go ahead.
report as well. No, go for it. Ask
I
me.
was just going to throw in one other thing, quick thing there. Next week we are doing a Virtuosity anniversary sale, so 20% off all of our Bentley products, including obviously OpenTower Designer, OpenTower Mount Analysis. So if you want to scoop up a license or two and check it out, I promise you that you will be impressed with the added efficiency of adopting this solution. Feel free to do that next week and get that deal.
No, that's good. Can I get the copy?
I'll give you 30% off.
Okay. So here it is, like, you can see that our reports are very neat and clean. We provide the information of each and every member class. Then we have a deflection profile there. You can always have the foundation design output. Let me show you in this video. So right here, the foundation design output with all
Oh,
the
perfect.
infos and everything. So report is already ready.
Yeah.
So that's where I wanted to show all these features.
Yeah, and
Yeah.
we can make the report. You can spit out every last detail about the tower if you want, or you can make it as slim as you want, depending on
Oh,
the
yes.
style you like to deliver it to your clients.
So here it is. Like, let's say if I don't want to see all this stuff, hey,
Just
what is my
trash it.
leg somewhere? Yeah, trash it. And I want to see that. I'll bring this guy and I want to say that, okay, from here to all the way here, I don't want to see. I want to see only the simple and easy to put.
Perfect.
It
And
has my
actually,
towers over there.
while we're on the topic of the report, are you able to open up the profile page?
Let's see. I think we might have it here somewhere. It's opening in my another screen. Everything is set up differently. So here you can see that. So this is our profile page, and there you can see that it will give you the information about what tower is designed for, what is the foundation rating, what is the structural rating, uh, structural weight also. We report that, which is very
Oh,
important, I
perfect.
believe, for yeah, because it's very important for users to aware of it. Like, when you are modeling it, so you need to know that what it is happening, right?
Mm-hmm.
And then it shows like all the sections, and if you notice that for each panel we are telling what are the section information, right? So all those legends are defined here for the user reference so that they don't have to worry about it. And
Loading,
then
summary
there's a
reactions.
loading. Yeah, this is the loading details, and then we have a tower summary reaction. So here you can see that for each type of, like, maximum, looking for maximum compression, tension, shear, overturning moment. So here is what I was telling, like, why we are different, that we are looking for, we are providing the user information, not only, hey, just give us the maximum, that's okay. You need to know that whether, what is the overturning for the, so let's say, serviceability, right? The uplift and all that stuff,
Mm-hmm.
maximum. So you have all that data for you to do it. And I know I didn't fill up all this data, but if you fill up all this data about the job project in the user setting page, you will have more information. You can push
Mm-hmm.
it.
And
And you
that's a
can spend
dynamic
this day.
image too, right there.
Oh yeah,
Uh,
right here.
You can move
Let's
around
say,
if you need to
oh
reorient it.
yes. So let's say if I want to do that, I want to say that, oh no, this view is not good. I want to show my feed lines more clearly. Okay, and you can
Perfect.
always zoom it, like, to a level to see that.
Yeah, and then just output this to PDF, give it to the relevant person, and they're
Oh yeah.
up to date on the latest on it. Okay, I think that's time, everyone. Thanks so much for joining us, and tune into the next one. We'll be doing these every 2 weeks for now. Thanks again, and have a good weekend, everyone.